So I am going to share screen. And if I look like I'm looking away, it's because I'm looking away.
Yeah, right.
My bigger screen is on the right of my laptop, which is where the camera's at. So you'll see me looking towards my big screen. So anyway, so as Travis mentioned, he asked for volunteers to kind of step in while Tim was away to maybe enlighten some folks at San Diego Fine Woodworking regarding Fusion 360. And we utilize Fusion 360 at San Diego City College, where I'm an instructor, for some of the manufacturing engineering coursework. One of the classes I teach is guitar building, electric guitar building. And in the electric guitar building class, we don't actually use Fusion in that class, but we do use it in some of the more advanced manufacturing engineering courses to cut some of the guitar bodies. We normally buy these as kits, but for example, this blue one is left-handed, and we didn't have any left-handed kits. So last fall when I was teaching this class, I had to figure out a way to get a couple students left-handed guitars. So I decided to dive in and bring up the Fusion designs that are available, which I'll explain in a second, and flip it so that it was left-handed, and then cut it on our CNC router in our manufacturing lab. So tonight what I thought I would go through is a little bit more of the CAM part, or the manufacturing workspace. I know Tim has been talking a lot about the design aspect of Fusion 360, but for tonight, what I thought I'd do is go a little bit more into how to do some of the CAM work. So
if I could just remind everybody, we had talked a little bit about the manufacturing. It came up in the context of how can we output to a 3D printer? And we found that we didn't have to go into manufacturing. There was a way of outputting that from just within the design menu structure. And then we talked about how to do output to Shapeoko, which is what we have in the shop. And we said that we'd get to that at some point. So I think we had aspirations of going where you're taking us, Ray, but we haven't actually spent any time in this area. So this is gonna be great, thank you.
Okay, and I'm trying to untangle my earbuds here. If that doesn't work, I'm just gonna forget. Yeah.
Well, while you're untangling, maybe you could just tell us about that one word you said on the last slide, which was kit. Guitar.
Oh, kit.
Kit.
Yeah, so we work with, and on this slide, it's a good segue. We work with an organization called STEM Guitar, which is a nationwide organization that works with high schools and junior colleges to teach guitar construction, but they do it in a fashion that incorporates STEM. So they not only teach them how to build their own guitar, but they teach them about math and engineering and so on and so forth. And it was also a good fit for our manufacturing engineering program at San Diego City College. So the organization that we purchased the kits from is STEM Guitar, and the website is listed here. It's www.guitarbuilding.org. The kits are not available for purchase by the general public. However, you know, they are available for learning institutions such as high school and junior colleges. Now, having said that, they do provide all of the guitar body designs in Fusion 360 off their website, and that's freely accessible to anyone.
That's cool.
Yeah, and tonight when I'm demonstrating the manufacturer workspace, I'm actually going to use their guitar body design to get us a head start on the process. So we're not going to design the guitar, we're just going to do the tool pathing for the guitar.
Hey, Ray, just because you mentioned that you can source these Fusion designs, in the 3D printing world, obviously there's Thingiverse with the superabundance of STL models. Are there places like that in the Fusion world where you can source Fusion designs such as this guitar, or do you have to find them on your own individually, like through guitarbuilding.org?
I think there are some locations for it, and actually when you're in Fusion, there are some sample files in there, but I don't know of any like user community that provides different designs in Fusion 360. I've often looked around for things, and I Google it, and sometimes I hit things. Also on Thingiverse and sometimes on Instructables, you'll find a Fusion or F3D file provided with the files, and then you can download and import those.
But that's more like they happened to have used it, so they happened to have uploaded it with their project on Instructables, for instance, right?
That's correct, yeah.
Yeah.
I'm gonna move this. Yeah, that's exactly right. And I actually put a few things up on Instructables. I think that's where I put them. It's been a little while, but I always include the Fusion file as well as the STLs and some other files. Okay, so a little bit about me. I've been a software engineer for well over 30 years. And about 5 years ago, or maybe more, I got the maker bug, like so many of us have. But I decided to even take it a little bit further, and I got an AS degree at City College in manufacturing engineering. And then one of my goals when I finished there was to actually teach. I enjoy teaching. My wife as an instructor there as well. So after I finished up, I went through the process of what was required to become an instructor there. And then last fall, I was my first semester teaching.
Oh,
so
cool.
Really excited about that, and it's a lot of fun. Now, this last semester has been a little more challenging because of everything.
What a time to start, Ray.
Yeah. So our guitar builders in our guitar building course dwindled from about, I think I had about 15 to I had, I think I have 3 left. Mike, who's on the call here, sorry, Mike, I'm going to put you on the spot, but he was in one of my classes. And we did not get to finish guitars, which accounts for the huge drop off. But I promised them that as soon as we can get back in the lab, they could all come back in and continue to work on their guitars.
Cool.
Yeah. And then again, San Diego City College, we utilize the STEM guitar. I mentioned that. The 107 is the guitar building course, but in the 100, there's some 100 and 200 courses that we utilize our CNC router in the lab to do various projects, not just cut guitar bodies, but there are other projects that we work on as well. So the CNC mill that, or router that we'll target tonight will be this Forest Scientific Luthier CNC. And this Luthier CNC is really just a CNC. It's a Luthier CNC because they call it that. It also has a really odd dimension. I don't know if you can make it out in the slide, but my X direction is much longer than my Y direction. And it's really designed to be able to cut a guitar sideways, if you will. So it's a very reduced format in terms of a CNC of this scale and of the power that it has. It has a very narrow Y direction, if you will.
Hey, Ray, just if there are luthier type insights you can share over the course of the next hour or whatever, you should know that the guy who founded our luthier group and who is the president of the luthier group and who holds the luthier meetings is Mike Davis, and he's here tonight.
Oh, great. Okay. Sounds good. And is that the Mike that was in my class? I forgot. Sorry, Mike.
Yes.
Yeah, okay. So yes,
Okay.
I know Mike very well.
Good.
Okay, so this, there's a few pictures on this slide. The left one is what we go from to what we go to. And these are, this is just a body blank. It's 22 by 14 and about 1 3/4 inches thick. We actually do in class, we pre-process these. So in other words, we will cut them down into the planks and then glue them up and go through planing and sanding to build the body blanks. But then on the right, you see the completed guitar body as it comes out of the CNC machine. The CNC we talked a little bit about, and then one important thing for later when we get into Fusion is this is the hold down apparatus that you see, and you see these 2 bolts on either end, and the guitar has features on both sides, which we'll talk about in Fusion a little bit, and it's important that it flips perfectly from one side to the next because you have a lot of holes that need to line up perfectly. So they incorporate, and this is the stem guitar idea that they gave us, is they incorporate this bolt down mechanism where when you flip, you just put a bolt through and then that lines everything up perfectly for you.
Do you know what the dimensions of that bed are?
I do our bed, the working envelope is 51 inches by 21 3/4 and about a 6-inch Z depth, depending on the bit that you have in there.
And the brand of that CNC is Forest Scientific?
Yeah, Forest Scientific.
Huh.
And for some reason, he targets luthier and stem guitar. All of the stem guitar manufacturing operations, which are in Sinclair, Ohio, they utilize their CNC. So I don't know what the connection is, but for some reason, he's got a corner on the market for this. For stem guitar, not necessarily luthiers.
Got it. And your spindle is really just a router, it looks like.
It is, yeah. And I mentioned it there. It's a Porter cable, the model, and then the RPMs.
Yeah. Okay, great.
It's a little bit challenging because the RPMs are high, and you know, at 10,000, even at 10,000 RPM, it's not a really great speed to be running a CNC router. But you know, it is what it is, and that's what we use. All right, so then to get more into Fusion, every process, like what Tim has been talking about thus far, has a workflow. And I just kind of outline the workflow that I go through. Everybody can do it a little bit differently, but basically to go from CAD to CAM and cut, you do the CAD design. You guys have been doing that. I won't go into a lot of the design aspects. Then set up the tool library. Now Fusion has a tool library. You can put it on your own personal computer, or you can put it in the cloud. If you start utilizing Fusion at San Diego Fine Woodworking Shop, I think it would be useful to set up your tools. I don't know how it works on the CNC in your shop as far as sharing tools, but if you do have a common set of tools, you could put those in the cloud library, and then people could access those.
And Ray, if you could, just for the benefit of those on this call who haven't done CNC, if you could clarify that tools are the end mills that people would be using in their library, right?
Yeah, typically end mills, ball mills, drills, those are the type of tools you would be using.
Yep.
Then machine definitions, and I did put the Shapeoko, that's what you guys have, right? I did define one just to show you how it could be done.
Cool.
We'll go through defining setups, defining some toolpaths, some simulations and verification. You can also produce a pretty nice setup sheet right out of Fusion. You just right click and say setup sheet, and it creates a nice PDF, which is great because we all forget sometimes, you know, what the job setup was, and it's kind of nice to be able to generate that right out of Fusion.
Ray, are you also perhaps a VCarve user?
I am, yes.
So there is a way of recording your project there as well as a PDF. Is that similar output? All the end mills, the profiles, the
yep.
drawings?
Yeah.
Same
We'll, I don't know, I haven't looked at VCarves in a while. I don't know the detail and the differences.
Okay.
But we'll generate one. I have a full toolpath set up for one of the guitars if we
Cool.
don't have enough time. And
Great.
then we'll just generate the setup sheet and take a look at it.
Well, if Tim has been any indicator, there is no limit on how much time you can take.
Okay. Well, I don't know about you guys, but my bedtime's pretty early these days. And then finally, you can transfer your G code over your CNC controller and then run the job. And I don't have too much more here. So we may come back to this. This is a G code and M code reference of all the codes I found in a generated file. It's obviously not all the G codes and M codes available, but they're the ones that when I looked at the G code file were in there. And then these are some resources, and I can send this to you, Travis, if you want to send this out to other folks when we're done.
Better still, Ray, we have a forum system where we have an ongoing discussion around these topics. We'll get you on there and you can just post it.
Okay, sounds great. All right, so enough talk, and maybe now we'll get into Fusion. If you guys have any questions now while I'm switching, feel free to chime in.
This group has not typically been shy. All the microphones are usually unmuted, and you'll hear from us all.
Oh, I've attended a few of these. I definitely know what you're talking about.
Okay.
All right, let's get Fusion open here. Okay, now I am on a fairly large monitor. I don't know what size monitor you guys have and how well this is going to show up. So if I need to zoom in more, when you're ready, or if it's too small for some of you, I can do that.
I'm ready.
Okay, I am in Fusion. You guys can all see that, right?
Yep.
Oops. Except it's showing the Fusion share bar right in the middle. Okay, I just moved it away. Okay, so what I thought I would start with is I'll show you quickly, well, we'll actually work with this file. This is the file straight out of guitarbuilding.org. And again, you can download these straight off of their website. They have multiple designs. I think they have 6 or 8 designs. This is a single cut. We're not going to work with this one. We'll work with the other one because I already have the cam set up.
Hey, Ray, does it come with the timeline at the bottom when you get it from them, so you can actually go back to all the various stages, or?
It does, yes. Because they designed this in Fusion, the timeline is intact.
Okay, cool.
Oh, I need to start one other thing here. Sorry. I have my cheat sheet on my iPad, and I want to bring my cheat sheet up. So we'll start with this base design, and then we'll start defining some toolpaths. If it gets to the point where you're like, okay, not another toolpath, let's cut to the chase. I have one fully defined, and then we can bring that up and then kind of highlight some of the features and functions of different toolpaths at that point.
Great.
So you see the design, the way, and again, this is straight from STEM Guitar. So I don't know the rationale. As you guys all know, there are more than one way. There's more than one way to get things accomplished, especially in CAM or in CAD. So for whatever reason, they've designed what they call the center tree, which are common components to all their guitar designs. You have your pickup pockets, your holes for your bridge, your strings, your neck pocket where the neck fits in, and electronics they've done in a separate sketch. But the common design tree they defined as a single sketch. And then you also...
That common design tree looks as though they are the symmetrical elements of the unit. And that may be the logic they use for those components being the design tree, the symmetrical nature of it.
Yeah, definitely could be. And they've dimensioned everything so that if you need dimensions on any of this, those are all fixed dimensions.
How did you reveal that?
All I did was edit sketch.
Yeah.
So on the sketch itself, right click, edit sketch.
Yeah.
And then that's when you see that.
Got it. You had it all there before, you just revealed it to us. Okay.
Correct, yes. And then to get back to my solid model or my 3D model in Fusion, I just do finish sketch, and then it brings it back to... Now, you'll notice the little eye here, that shows the sketch along with the 3D body. If I unclick that, all I see is the sketch now. If I click on the body, but then I take the sketch off, I just see the body. And you can toggle these back and forth. So if I want to see the back drill points, for example, this sketch, they're showing up now, and then I can hide those again if I need to. Okay. So pretending that we are completely done with our, whoops, they orient things a little bit differently than I like to do it. So it's a little bit different. But this is my design workspace. And again, if you recall from what Tim was mentioning, in Fusion 360, you have these different, what they call workspaces. The design is where you're doing your 2-dimensional and 3-dimensional design work. I won't go into any of these other ones. One thing I want to mention real quick, I have the education license for Fusion 360. I don't know what licenses you're working off of for the folks that are on the call.
Hobbyist to a great extent.
Say again, I'm sorry?
Hobbyist and non-commercial, the one that is
okay.
basically
Education.
Don't get any manufacturing. Sorry, go ahead.
You should see manufacturing. What you may not see is this generative design. So as I go through some of these, you may see additional menu options that are not normally available. But we're just going to skip down to manufacturer. Okay, and you can see very little has changed at this point. However, at the top, I'm in milling. So I'm working with a milling type machine is what they're assuming here. You can also work with a lathe or a turning machine, additive 3D printing. You mentioned 3D printing earlier, Travis. One thing that I just realized tonight is I can actually generate my my G code, I believe, for my Prusa printer directly out of here. I know you can create an STL.
Yeah, that's the one piece that we've seen is Prusa and being able to generate the G code, in addition to just being able to output the STL. But we kind of concluded the workflow for 3D printing, if this manufacturing additive was going to be costing us each month, was to just output STL and then go into Prusa slicer and generate our G code out of there.
And that's what I typically do. I do a lot of design for things in Fusion, but then I just do the print 3D print option and create the STL. And Travis, I'm not monitoring chat either. So if people are chiming in on chat, would you mind?
I'm happy to read you questions. Absolutely.
Okay. All right. So we're in billing. Again, let's go through our workflow. The first thing I believe I had on my workflow was either manage the machine or manage the tool library. So what I'm doing is I'm going over across the top here, and there's this manage button. You can manage machines and also tool libraries. I'll go into machine first. Now, Fusion has several machines that are defined by default. And you can also filter it out. So if I just want to look at milling, for example, I can check just milling and you can see what they have. Now, they don't have a lot of hobbyist type milling machines. They do have Haas machines in here. And then some of the other folks here. What I did initially is I just defined an Autodesk generic 3-axis when I first started working on this for tonight. However, you can copy this and then you can paste it either into your local machine or into your local cloud. And then you can redefine it. So I defined one from the generic called the Shape Oko and set up some of the, let's see, there we go. Set up some of the dimensions on the machine. I believe if you have 0 in here, it's just unlimited. So in other words, my max feed rate at 0 basically means it's undefined at this point.
Right.
So this was just quick and dirty last night, but I did want to show you that you have the ability to define a machine specific to your needs within Fusion.
Yeah, there has been a post processor available for Shape Oko within Fusion for several years. So I'm surprised it didn't show up in that list that you were looking at.
Yeah, it actually, I'll show you that in a second here. Post-processing, it does show up as carbide3d.cps, I believe. Is that the one that you use?
Yes.
Okay. So you can select multiple post-processors. I did a little research last night and it looked like the Shape Oko used the carbide3d CPS. So the nice thing is once I assign my machine, it automatically associates my work then to that post-processor. So when I generate the G code, it will automatically know that that's the post-processor I want to utilize.
Yeah.
Okay, so that's my machines, and I'll assign this setup to a machine. But before I do that, I wanted to also talk about tool libraries. And Fusion has the ability to, they have a lot of different tools that you can go through a vendor list and you can pick from different tooling companies and so on and so forth. For my need in the manufacturing lab, I defined my own tools. Now I did put them on the cloud. That's so that when I'm in the lab, I have access to the same tools as I have here at home. Whereas if I did it local, these are all my local definitions, it's stored right on your machine.
So in your class, when people do the cuts for the bodies using this Fusion file. These are the tools that define the extent of what they need. There are 5 end mills of different types that they use.
Correct.
Okay.
Yeah. Now, a little bit of back history too. I cut out those left-handed guitars almost a year ago. Well, no, not quite. About 8 months ago. Last night when I asked you if it was okay if I did a presentation, I redid everything and I have no idea what I did 8 months ago. So I redefined these 5 tools last night.
Nothing like putting pressure on yourself, Ray.
Well, it was actually a goal of mine to get this all done and actually do it in the lab this semester with my students. And because of everything, it fell by the wayside. So you actually
helped
got me
catalyze.
going again.
Good.
So yes, the 5 tools that you need to cut the guitar body and drill holes are the 5 tools I've defined here. Now I'll go in and I'll edit one of them so that you can kind of see the different options you have available.
Were any of these based on, I purchased it from a particular manufacturer with a particular part number and therefore everything was filled in automatically? Or are these things you had to set up individually because these are the end mills you just happen to have?
They are the end mills that were supplied with our CNC machine.
Okay.
But on the side of the end mill, it gave me a part number. Mm-hmm. And then through Google searches, I was able to find the vendor. And then from there, I was able to find the specifications for the end mill.
But you had to type the specifications in as opposed to have it being automatically populated.
That's correct. So everything you're seeing on the general tab here, I typed that in.
Okay.
And the only thing I had on my tool, my 1/2-inch end mill, was SRD 263.
Okay.
But you know, all I did is Google SRD 263 end mill, and it came right up. Now so the description I made up on my own, but then the vendor, the product ID, and then you can actually put a link into the product for the product link, and then you can go off and reference that if you need to. That's the other advantage of having this in the cloud, is because you can share this and it's accessible for anybody in the cloud if they want to. For the cutter, you can specify all the different attributes for the cutter, whether or not it's a flat end mill, and then you can see all the different types of tools that are available. Most common that are used, at least with what we do, are flat end mills, a ball end mill, and then drills.
Yeah.
But you can see there's a huge variety. Number of flutes, the material, carbide, whether or not you have through tool coolant, the spindle rotation, and then the unit. Now, interestingly, we have drills that are in millimeters, but our end mills are in inches. So you can specify by tool, regardless of what units your design is, you can define your tools in the units that are appropriate for that tool.
Cool. Then
you can define the different geometry. Some of it will auto-calculate. If I said flute length 1.75, I think if I change that to 2, you can see the body length adjusted accordingly. Say again?
So you adjust the flute length and you already have the shaft length, so it just comes up with total length?
Exactly, yeah. But anyways, these are some of the tool attributes. I do want to point out number of flutes is important, because if you're trying to get chip load per tooth, this is going to make a difference when you define the tool. And then we'll get to the feeds and speeds, but you'll be able to get the chip load per tooth based on other parameters you put in. Shaft, I leave blank. Holder, I leave blank, or the default that they provide. Then feeds and speeds. So again, I was putting this together last night. Don't take these numbers literally. I mean, I tried to use numbers that were provided to me at a workshop, but before I would actually cut this guitar, I'd want to go back and verify these to make sure that they're appropriate.
So these weren't provided by the manufacturer from their website? And
they were not, no.
Okay, and you didn't use something like GWizard, that app that actually says what the speeds and feeds might be for different end mills of different characteristics? That's not, so you just did this based on what you kind of knew?
Yeah, I knew the spindle speed. We run it at 10,000 because that's the lowest RPM that I can run on my router. And then from a workshop, I took the numbers 60 and 30 for everything else. Cutting feed rate is 60, and then the lead-ins and plunges are half of that. But again, don't take these numbers as being correct. I put them in. I know they're somewhat reasonable, but I don't know if I would actually use them when I actually cut this.
Right.
Now, also going forward, when you define these parameters for a particular tool, you also have the ability, when you create the toolpath, to modify them for that specific toolpath. So it will carry, and we'll see this in a second, it will carry this forward into the toolpath, and then you have the ability at that point to override that for that particular operation.
So this is your library definition, but for any given toolpath where you use this tool, you can modify.
That's correct. Yep. And then post-processor, if you have a automatic tool changer, you can set your tool number. We don't, unfortunately. I assume you don't for your machine, or do you?
Say it again, please.
Automatic tool changer?
We do not.
No, we do not. Don't we wish we could, though?
It's the manual method.
I definitely wish we had ours too. But you can check manual tool change, and that will change the G code depending on if you have an ATC or not. Coolant disabled. Some of these have no effect on, especially like a wood router, you wouldn't want coolant running. So that's pretty much it for the tool definition. Drills look a little different when you define them. The cutter, you've got a tip angle and some other parameters that are different. And those are all defined by the fact that you've set the type as drill. So depending on the type, it will have different parameters and different settings. Okay, before I move out of the tool library, any questions, comments?
I only had one, Ray, which is if you had wanted to use an end mill that was from a major manufacturer of end mills, it would have filled in everything for you automatically? That's a question.
If you go down to like Tormac,
yeah,
and I find a tool that I like, you can copy this tool, stick it in your library, and then either change it or leave it as is.
Okay, so it comes with all the defaults that it would expect.
That's correct, yeah. Okay. And then they have all these samples like metric, aluminum, 118 drill. Yeah, you can copy any one of these over, and then you're allowed to edit it once you have it over.
Got it. So it gives you a starting point.
Exactly, yes. Okay, so I will close this. Now you'll notice there's no save. Anytime you're working with the cloud, either in the machines or in the tool library, there is no save anywhere. You just close out because it's in the cloud. Okay, so now I'm going to bring up my cheat sheet. Okay, so we talked about tool library. So now let's talk about setup. Now, remember that this is a two-sided object that we need to cut on our CNC. So I cut the back first, just my preference when I was cutting these. So there's an electronics pocket down here. There are some ferrule holes for mounting the ferrules on the back of the guitar. And I believe, and then we're going to cut the two, or drill, basically end mill down the two holes for the bolts that we're going to use when we flip it.
Hey, Ray, just because we come from a V-carve background and there are distinct ways to go about setting up a two-sided cut, do you have to know with Fusion the right approach to doing a two-sided cut, or are there guides on how you'd go about doing it? So it just made it easy for you to flip from one side to the other and make sure that you can stay exactly in the right right positioning when you're defining it. You can look through to the other side and have it sort of cast to the foreground so that you can see where you were. I mean, is there a process in Fusion for defining a two-sided cut that is sort of aided with little prompts and insight?
Not that I'm aware of.
Okay, okay.
I do two completely different setups, and I call it, and actually what I'll do is I'll bring up the completed one to answer some of these questions. So I defined a setup back and a setup front.
Okay.
But that's just my preference, or that was the way I defined it. But there may be something like what you're talking about. I'm just not aware of it if there is.
Okay, great. Thank you.
So question.
Sure.
So when you are doing a two-sided object, are you doing them relative to your, call it your indexing holes, or just component pocket to component pocket? I'm just looking for the only reference between the front and the back are the indexing holes. So would you have to use those to get proper orientation and placement?
You could use any technique that you come up with that you would deem reliable. I hope that answers the question.
Yeah, I guess I was looking for like a central datum point. And if it's the indexing holes for front and back, or electronics pocket, or neck,
I see what you're saying.
whatever. Yeah. Okay. All right. Thanks.
I mean, that may be possible, but when we do a setup here, it might answer your question. But I don't know if I have access to individual points on features in order to make that my datum that I would locate up both sides on. But we can locate like the edge of the stock or the middle of the stock and things like that.
Okay. Thank you.
Sure. So I'm going to do my first setup. So to do that, you go up to the setup and just say new setup. And again, we'll talk about, we talked about the machine. So we'll select, and I'll do the shape OCO since I have that defined. It's an operation type of milling. My orientation is the model orientation. Origin is my stock box point. Most of the things that you do in here, you can get away with leaving them as the defaults. And then what I find myself doing is take the defaults and then work with it. And then if something's not working exactly the way I like it, then I go back and I see how I can change it, rather than trying to nitpick through all the different options and figure it out from that point.
And did you, I'm thinking about, you showed us a cut. You had some laminated wood. There were two parallel darker woods. And so you choose your origin on this one to be the center point, so you can actually position it right between the two darker wood strips in your stock. Is that right? Okay.
Yep. Yeah. Now, one thing I did change is the WCS. And the reason that I change it is you'll notice these axes, Z is up. That's all good. But Y is to the right and X is down. And that's not going to work on my CNC router. So, because I remember that I have that long X direction and a shorter Y direction.
Right.
So without going into the design, which is actually what I did last fall because I didn't know I could do this, I had to reorientate the entire design so that it was oriented the way I wanted it on the CNC router. But instead, what you can do is you say, I want to select my Z and X plane, Z axis and X axis. And then for my Z axis, I want to select, let's see, my XY plane. So I'm going to try to do this. Let's see, X, XY. There we go. And then my X axis, I want it to be my XZ. Now I did this ahead of time, fooling around with it.
What you're doing is you're moving around until you actually see the plane represented in that square, and then you say, that's it.
Yeah, you notice if you move, like right there.
Yeah.
I know that that's my, well, you can't see my finger, but I know that that's my ZY plane.
Yeah.
Or no, my ZX plane. Is that the way? Yeah, that's the way it is. Now, my X is now, something happened here. Oh, I know it. There we go. So now Y is this direction, Z is up, and X is right and left.
Got it.
Okay? And remember, I'm doing the back at this point. Now, when I do my setup for the front, I'm going to flip my Y, and all you have to do is, or flip X. No.
Flip Z.
Actually, I need to flip Z because I'm working on my back side. Sorry, I'm moving around here. Okay.
And so again, this is in your setup, and it is your work coordinate system that you're changing to reflect the dimensions of your bed.
Correct. And the directions of the bed. So Z is up, as usual, X is across, and then Y is in the narrow direction, if you will.
Got it.
And I'm working on the backside now. When I flip it, the Z will be flipped to go the other direction, and everything will be opposite.
Got it.
Sometimes it takes a little bit of working to get it the way you want it, but that's how I have it set up. And again, I'm working on my cheat sheet from last night. So everything else I left is default at this point. Now stock is telling you the actual material you're working with. What it's done, that yellow outline is the stock that I'm working with. What I like to do is define my actual stock, which I mentioned is 14 inches by 22 inches. So what you can do is change the mode so it's a fixed size box. And I'm going to say it is 22 inches by 14 inches. And my height, Z, is 1.75.
What is the Z possibility on that particular machine, the range?
6 inches,
Very
but
good.
it depends on the end mill size, but approximately 6 inches.
Cool.
Now, one thing you'll notice here is my my holes for my bolt hole is hanging over on one end of the stock, because what it's done is position the guitar body in the center of the stock. Well, that would be a problem because my through hole here for the hold down is not going to work. So the way I did that is I adjusted the positioning so that it's an offset from the left. And I set it to 5. And you can see it moved my entire stock down.
Yep.
So now I have my 2 through holes, and basically it moved the guitar out.
Yeah.
All right, let's see if there's anything else I did. Nope, that was everything there. And post-process, I left as is. Basically, all you do is you put your program number here in a comment, but at this point, I just left it as the default. So if I got it right, that completed my setup.
How do you know which post-processor you're using?
When you, we don't have any, well, let me jump over to the one that's already done. If I want to generate the G code, you do post-process. It's a little confusing because generate regenerates toolpaths, but the post-process is actually generating G code. When you do that, it will ask you the post-processor that you want to use.
Wait, could you say it again? What was the difference between generate and post-process?
Generate is if I want to regenerate the internal G code, if you will. In other words, the toolpath definition for the operation.
The not machine specific G code.
Correct.
Okay. And then the post-process is making it machine specific.
Yes,
Okay.
that's a good way of thinking about it. Yeah, it's
Okay.
a little confusing because most people think, oh, I'm generating G code.
Yeah.
And trust me, I do it all the time. I right click and hit generate, and
Yeah.
it'll come up with this warning and say, well, wait a minute, you already have a valid toolpath. Do you really want to generate it? It's like, no, I wanted to generate G code. So,
Yeah. Yeah.
So anyway, I hit no, and then I go back and I generate I post-process to generate the G code. Okay, so let's go back to my bass guitar, not a bass guitar, but the bass one that I was working with. And again, I'm working on the back, and the first operation that I want to work on is to cut out this deep pocket here for the electronics. Now, the way you do that is, so the different toolpaths are up at the top on the toolbar, and you can see I have 2D toolpaths, 3D toolpaths, and drilling. I have not experimented a lot with the 3D toolpaths, but just know that they're available and they're there. All of the operations we utilize are 2D. So I'm going to say a 2D pocket.
I'm sorry, is that menu structure what shows up when you choose to be doing a milling operation?
Yes.
Okay.
Yep. And you can see I'm on the milling
Yes.
tab up here. Okay, so my 2D pocket that I'm going to define, I'm going to first select the tool, and I'm going to go to my MFET guitar tools. I'm going to use a 1/2 inch flat end mill. It's a pretty big pocket, so I'm going to use the biggest tool that I can use. So I selected that, coolant disabled, and you notice all these speeds and feeds pulled in, so I don't need to do anything here.
Yep.
Then for geometry, I don't have it selected yet, but what I can do is just select the geometry that I want to, in this particular case, I selected the bottom profile of the pocket. Now, there are different ways you can do this. I could actually select the top, but then I have to change depth and so on and so forth. For me, doing a pocket, it's just easier to select the bottom of the pocket.
I'm sorry. So geometry is such a generic term there. It sounds like, from what you've just said, we're defining the geometric shape that we want to end mill down to.
Correct. That's the way I do it.
Okay.
But, and we can try this like nothing selected now. And if I select up here, it's actually thinking that I need to go down to that's my bottom, is actually that upper part there, not the bottom of that pocket.
Yeah, yeah.
Now you can play around with, and there's a heights tab in a passes tab where you can tell it, no, sorry, it's on the heights tab, where you could say, oh, I want to go down, but then I manually have to say how deep I want that pocket to go. It's just easier to say, this is the bottom of my pocket.
Do you set 0 on your workpiece to the top surface or the bed?
So I do at the top of the stock, but I've heard arguments for doing it to bed.
We all, by default, do the top of the stock too. I was just curious what you did. Okay.
Well, actually, the bed makes a lot more sense when especially when you're dealing with wood. But my brain doesn't wrap around it quite yet, so yeah. I do top of stock.
So here you've chosen the bottom geometry, and it knows to go from 0 down to that as defined by that shape.
Correct. Yes. Okay. So I didn't have to do anything else in here. And again, I leave things as defaults until I feel like I want to change them. But there are other options like rest machining, for example. The nice thing about Fusion is if you hold the mouse over, it often will give you a little picture tutorial of what it is these options are going to be asking you for. Rest machining, basically if you have 2 machining paths or two tool paths for the same feature, it will know, oh, well, wait a minute, the first tool already roughed out some of the material, for example. I don't need to go back and redo that again with a finer tool. So rest machining means it's going to do the rest.
Oh.
And that'll cut your time about 50%.
Yeah, exactly. I mean, a good example here is when I do this shoulder, I'm not going to use rest machining, but I don't need to cut out the center part of that shoulder because I've already done it with that pocket.
It knows it's been done, yeah.
Okay, heights. Now the heights are the different heights that you're going to operate with. So move this over a little bit. There we go. And then it gives this nice pictorial of what's top height, what's clearance height, what's retract height, and what's feed height. Again, I kind of leave things as defaults in here. The one that's critical is the bottom height, and I've already selected that geometry, so it's saying selected contours is my bottom height. If I wanted to change that,
I'm sorry,
you can select different heights.
If you've defined your stock to be 3/4 of an inch, that's what it's assuming is that dimension?
In this particular case, I'm not going through, but on a through hole, you would select the contour, but you can also say, I want to go all the way down to my stock bottom if you wanted to. Now, the other nice thing is you can also provide an offset. So if you're doing through holes, and you usually want to go down into your spoil board a small amount, it will not know to do that. You have to add a little bit of an offset in order to make sure you go all the way through.
Got it.
Okay, let's see. I got this right. Okay. passes. Now, passes are important because you don't want to just take your end mill and drive it straight down into this deep pocket. So what you can do is say, well, let me point out some things on the default, first of all. Stock to leave, it seems to always default stock to leave to 20 thousandths of an inch. And what that's assuming is I'm doing a roughing operation, and then I'm going to come back with a finer tool and then finish that off.
Yeah.
In our operation, it's the guitar builders that are doing the sanding, and we let them do the finishing. So I'm going to take stock to leave off, but I am going to say multiple depths, and because I don't want to go down all the way to the bottom of this with my end mill.
But isn't there a default on that, like related to the diameter of the end mill or something?
I haven't found it if there is.
Wow.
And I do find that kind of odd that it doesn't automatically
Right.
say, hey, you know, it will go all the way to the bottom if you decided.
Oh my gosh.
If you don't change this. Matter of fact, any time here, you can hit OK, and it will generate the toolpath for you. So you can visually see this is going to spiral down and then cut out the pocket.
One step, yeah. Jeez.
Yeah. But that is one nice thing about Fusion is at any point in time, you can just save that operation and kind of get a really good sense of what it would do.
Yeah, but you know what? The one better thing about Fusion would be if it had a default that made sense.
And again, Travis, there might be a better way, and there may be something like that, but I'm just not familiar with it.
Got it. Okay.
So does that just ignore the feeds and speeds for a particular tool bit? Because there is a limitation on the feeds and speeds on each bit, right? You can't
There
just
is,
talk about that
and
material
all this,
from the past.
yeah, all the speeds and feeds are here, but you never said what's my max depth per cut.
Yeah, it's just a variable of the depth, Paul, that he's talking about.
Okay. Okay, got it.
Yeah, I think it's usually called a step or something, or step down,
Right. And
and that wasn't defined.
so the way I learned to do this in Fusion, and there may be another way to do this, but I go down, I say multiple depths, and I do half my end mill,
Yeah.
so 1/4 inch. I don't do any finishing step downs. So this number, this finishing step down is irrelevant because I don't have any finishing.
Sure you do. It's called your students.
That's right. And then for whatever reason, the person who taught me how to do these toolpaths on guitars said always use even step downs, but never gave me a reason why, but I continue to do that. So,
It takes the whole distance and divides by the number of paths and just does an even amount each time.
I guess, or that last cut, it does either a little bit less or I don't know. It doesn't ever go more than 1/4 inch.
Got it.
Okay, so that's my passes. And my linking I've left alone. I've taken all the defaults there. There are lead in, lead out type options if you do lead in, lead out. If you'd like to do that. The ramp in is a helix, which we saw in the toolpath. But again, I'm going to leave everything as a default.
Hey, Tim, can you pause? Because there's so many things that we've covered.
Oh,
From the time
sorry,
that you left design at a very high level, you came in here and you set up your stock, and now you're setting up toolpaths. Is that correct?
yes.
Okay, so those are the two things that we've done so far. Define stock, define toolpaths. And we've just done the one for this one pocket.
That's correct. And before we did that, we defined our tool library.
Right, which we wouldn't normally have had to do because we would have our tools in our library.
Right, defined.
Okay, good.
But yes, as far as workflow, first thing is setup. Second thing is to start doing your toolpaths.
Okay, great. Thank you.
I have a quick question. I don't want to get ahead of ourselves here, but I assume you could do those 3 holes for the control knobs here in this. I assume it's possible. Is there a reason that you're doing it? It sounds like you're doing that on the other side.
I'm actually going to do the holes on this side.
Okay, okay.
Yeah, and I'm going to use an upcut and mill for that.
Okay.
So
So that's
but
why
I roughed out the pocket, and then I only have that little bit of the hole left. Sorry, I might have stepped on you. Say that again.
What was that, Lance?
No, I got it.
Okay, cool.
Thank you.
One thing that was important here on the linking that I did change, is this is where the step over is, not step down, but step over.
Yeah.
Let's see, where is that?
This does provide defaults though.
Yeah, see, that's the thing. Why do I not see a step over here? I'm sorry, guys, I'm not seeing step over, but I know it's important. Oh, maximum step over right here. So this is also something that I generally do half the diameter of the end mill.
Yeah, it actually put 0.47 in there.
Yeah, it did. Yeah. Yeah, it was a pretty big chunk.
That's huge.
Yeah. And, you know, depending on what you're doing and the type of wood and everything, you may even want to reduce this even further.
I was going to say the rule of thumb that we have talked about in our CNC class is about 40%. Because if you think
Okay.
about it, that's the cutting up to the midpoint, you know,
Right.
of the diameter.
Right. And I wish there was a way to, like, you know, hit a button that says optimize or for
Yeah.
wood or something like that, but I haven't
come.
seen. Okay. So I'm gonna hit OK here, and it now generated my toolpath. And you can see, so we'll simulate that. But one thing that came up here was this little yellow warning. And if you click on those, it kind of gives you an indication of what the problem is. But it's never really super clear. But what I did identify last night when I was working on this is says from the highest Z position of the toolpath, the safe distance linking tab is higher than the specified feed height. So what I did is I went back and I edited my toolpath and I went to the linking, and it says the safe distance is 0.28 inches. And I'm going to hold the mouse over that and let's see if it, so minimum distance between the tool and the part surfaces during retract moves.
So is that the travel height above the surface?
But yes, but when I go back to heights, these should be the heights for things like retract and feed height and so on and so forth. So to get rid of this warning and know that I'm doing everything safely, I just went back to my heights and I saw that 0.28. And what I did is I changed my feed height to 0.3.
Okay.
And I changed this to 0.4.
Just making the software happy. Is that your goal here?
Exactly. And knowing that I'm in a safe operating, you know, distances or envelope.
Sure.
And I also changed it to stock top because I know that's the positions that are most important to me, is I want to be above my stock.
Definitely.
So I just adjusted all those manually. Say again?
Unless you had large clamps.
That's right. Yeah, the clamps actually would be important. And there is a way, I think you can even define where clamps are positioned in Fusion, and then it will tell you, you know, there's a problem. But so my yellow warning went away. And at this point, I've done my first toolpath. And now what I can do is, which I think is one of the coolest things, is I can simulate this. I can show my stock, and then I can run my simulation, and it will actually show, you know, the tool operating and whether or not it's giving you what you had expected when you define this. You can speed this up, or you can actually go in reverse and undo. If you're like, well, wait a minute, what happened there? I can back it up and watch it go backwards. If you have multiple operations you're working with, you can skip to the end of the operation. So the simulate's a pretty handy feature. I don't remember what's in VCarve. It's been a while since I've been in it, but if they have simulation mode.
Yeah,
like
they do. They do. Not as pretty as this one, but yeah, they do.
I think there's also a way to stop on, yes, there's also a nice feature, stop on collision. So remember when you went in and defined your tools in your tool library, if my shaft length here or my end mill length was shorter than my pocket and I would have collided into my stock, it would stop at that point and say, well, wait a minute, you just had a collision.
How does it know how much of the shank you've put up into the spindle?
Because you define that in your tool, you tell it not only the shank size, but actually, I forget the term they use, but the exposed amount of shaft that's outside the holder.
Very cool.
Now, again, it's doing it based on what you tell it.
Right, of course.
So if you're off, or you have somebody who mounts the tool deeper than you're
You
supposed
mean
to.
reality rears its head?
Yes. Okay, so we'll go ahead and close the simulation. Now, let me go back and see what my next operation was. I'm wondering, again, how are we doing as far as, like, do you guys want me to see me define all of these toolpaths, or would you prefer I like do a drill path, toolpath to see that instead of a whole bunch of pockets?
People tuck up.
Well, I'd be interested to see
Oh,
at what point in time you do a flip and indexing against the flipped workpiece.
That'd be cool.
Okay. So why don't we do this? We'll define my toolpath that does the holes for the mounts, and then we'll start working on the other side.
Cool.
And we can always go back and forth too. Okay, so I believe what I did on that, let me find this in my notes. Clamp holes. Okay. So for my clamp holes, you can see those are they're at the top of the the front side, but the bottom of the back side. So again, all I'll do is I'll do a 2D pocket in this particular case, and I'll define, but I'll use a 1/4 inch end mill for this. We'll leave everything, well, we don't need flood, it doesn't really matter. For the geometry, I'm going to select there. Now you'll notice what it did is it highlighted as if it was doing an outside of that feature. So all you have to do is click on the arrow, and now it does it on the inside.
Oh, interesting.
Now in this particular case, I have two features I want to cut in one operation. So I'm going to go over here and I'm just going to click on the second one and then click on the arrow again. So now I'm defining both of these as the feature that I'm going to cut with this toolpath.
Ray, is that a convention throughout the milling, that if you want to do the inside of a closed vector versus the outside of a closed vector, that you would click on an arrow there and it just toggles between the two?
Yeah, but it's also dealing with conventional and climb cutting.
Okay.
So I believe there's in one of these tabs, you tell it if I'm doing conventional or climb. So in other words, if I click the arrow, but it's going to do a conventional cut and I'd rather do climb, I think you have to flip it to climb, but also then it'll keep it inside that
I see.
vector.
Okay. Okay.
Okay, let's see. Clamp holes. Did my geometry, my heights. We're going to leave that as a default right now. We're going to see if it complains. Passes, we got to go in and change. And you notice it always wants to leave this stock to leave. So I always got to remember to go turn that off.
It just assumes that people will plan for a finishing pass. Is that right?
I think so, but then what happens when you define the finishing pass? You know, is it doing stock to leave?
I would expect not, but yeah, I see what you're saying, yeah.
Okay, I'm going to try to go through this. Let's see. Where was my step over? Oh, I already did my step over. Okay.
I'm sorry, Ray, what are we doing right now? At Paul's request?
We're doing these two through holes for the pull down bolts.
Okay, and so you wanted to do that while we were on the back before you flipped it.
Right, because I'm going to show you these going through and you can visualize
Got it.
the operation even when we're doing the front side.
Got it.
Now, one thing is I want to do on the heights is this is where I want to go all the way through plus some into the spoil board. And sometimes I forget, like offset, do I do negative or positive offset?
Right.
If I forget, then I usually put in a large value, like -1 inch, which I would never want to do, and then hit OK. And then I say, oh, yeah, that's going through.
Yeah.
So then I can edit again and then change it, because if you put a plus in there, it'll actually raise it up rather than the direction you want to go. And then if I zoom in, I can actually see that tool path just slightly went below the stock. Whoops. Sorry about making you guys dizzy. Okay. And you can even simulate that if you need to. So you can see it spiraling down, and then it will feed over the top of the stock.
It's amazing that a collet can do that without a spindle behind it.
You can even take the tool out, and then all it is the, oh no, there was a way to take the holder out, I think.
Oh, is that right?
Yeah, I forget how to do that, but yeah, you can have just the tool going. Okay, so let's assume that at this point we've got all the operations done on this side. Now what I can do is I can go back and I can define a new setup. And at this point, I want to, my WCS, I gotta remember how I did this. Okay, select Z and X, and then I flip.
Flip Z with Z0 still on the same plane as before?
Yeah, I gotta, my Z was this plane.
Can you duplicate the setup?
You know, I tried to do that last night. Let me see if I can do that.
And then just check Z, like flip the Z.
And then flip it. Let's see if I can do that. Copy,
Just thinking out loud.
paste. There we go. We are learning together. Now that kept everything the same, you're right, but now I can go in and I can flip Z and I'm okay. Now, so something to notice there. So I'm on my front, and when I edit this, the other thing is my origin is stock box point. And I can,
What?
so I can tell it where the origin is for this side.
But what does stock box point mean?
So basically I can pick one of these points on the stock. So if I'd like to do corners, for example.
Oh, okay.
So all it's doing is I'm clicking that and saying which point on my stock do I want to make
Got
a
it.
order.
Where there are a bunch to choose from.
Yes.
Got it.
And it's visually doing that, and then as soon as I leave this operation, these little dots go off.
Got it. Thank you.
So let me double check here. I have Z up, X in this direction, and Y in this direction, and this is my front side. Let me go back. I want to check to make sure that my origin was on the back
Flip
side. Yeah.
rotating around X or on round Y. Are we still going? Is the neck still going in the positive X direction?
Yes.
Okay.
Positive X. This is my backside.
Okay.
But let me go switch back to my. So see how it's now. This is a front side, and X is still positive to the right.
Yeah.
Z is up, and Y positive is towards the back.
Okay.
But if I do this one and I flip, oh no, wait a minute, I got something wrong here. Because my Y should be flipped.
Yeah.
Sorry, guys. Why is it not flipped? I'm going to go back over here. I'm going to go back to my cheater page. Okay, so this is back, this is front. Y is to the back. Yeah, see on this one I have it right because Y just flipped. So let's see what I have different. X, Y, X, Z, Z is flipped. X, Y, X, Z.
I'm concluding that life would be so much easier if you didn't need a pocket for electronics.
I don't know how I got it. See, this is the part that I always got to muck around with. Oh,
Did
no,
you,
that's-
did you have one that was already done so we could just jump to it?
Yeah, that's what I have over here.
Okay.
This is the one I defined last night with all the toolpaths. So we can just jump to that if it's helpful.
Yeah, it looks as though your coordinate system is correct there, huh?
It is, and you know, even last night when I was doing this, I remember having to kind of muck around until I got everything the way I wanted it to work. Yeah, you can see on the back, when I do the flip, my Y is to the back. And then if I go back up to here, oh, that's my back. My Y just flipped around as if I'm flipping it over.
Yep.
Okay. So yeah, let's work with this rather than defining all the different toolpaths, and then we can work off of these. So what we can do is we can simulate the entire. So this is backside.
Mm-hmm.
Let me move this up. And that's the pocket that we were doing before. And like I said, we can skip operation if we're tired of seeing that. That's the shoulder. These are my two mounting points.
Oh, so that's really all we do on the back is the pocket.
Now I'm doing, someone asked about the holes.
holes.
Oh, okay.
And then these are the ferrule mounts, which is a drill operation.
Oh, okay.
And then these are, I actually do the, where the neck mounts to the body. I drill those holes from the backside as well.
I see. Okay.
Now it's actually flipped over to the other side and started those operations.
So where's the origin?
The origin is the center of the stock for the back when I cut it. And then because I drill my two mounting holes, those aren't the origin, but now I know exactly where those are at on the other side. I don't mess with the origin of the CNC when I go from front to back.
Do you have one body of G code which you run and it tells you when to flip and pauses, or do you just export a front G code file and then a back G code file?
So our CNC gets confused by tool changes, and I need to work on that a little bit in the lab to figure out how I can send it one G code file. Unfortunately,
Right now you do
last
two.
fall, no, I actually had to do more than that. I had to
Oh.
generate a G code file for every tool.
Oh, okay. Okay.
So I could take these two operations and splice them together because on the back with T1, it was the same tool. But
Right.
then T2 used the same tool. I have one G code file, then T4 and T5.
But you couldn't actually if they were on the front and back.
No, well then at the end of the backside, I flip the entire thing over, I bolt it down, and then I start yet another G code file at that point.
Yeah. Okay. Okay.
And all I do on that is I go back to where my origin was that I defined on the backside,
Yep.
and then touch off in Z because I changed the tool.
Yeah.
But then I don't mess with X and Y. That has to stay the same.
Yeah. Got it. Okay. But ideally, if your tool changer was working, you could get it down to 2 files or maybe even 1. Can you have it just pull aside and wait for you to flip the stock and then have it continue on the opposite side?
Well, there is a G code. I forget which one it is, but there's a pause or a wait operation,
Okay.
and like a wait with message or operator wait.
Got it.
And
And then you would
if
flip it
it's
then.
If it supported that, you could say wait for operator, and then the operator would then know to flip it over and then restart the program.
Got it.
I think the M6 does that. At least that's what I saw on mine when I generated both finish or rough and finish together. In the middle was the M6 command and then the tool to change it to.
Yeah, the M6.
And then I got to.
Well, M6 is definitely a tool change, but you would have to know when it comes up with that tool as the operator that it also is time to not only change the tool, but also to flip it over.
Ah, right. Right. Okay.
Okay. Oh, now I lost. There we go.
Hey, Ray, do you play the guitar?
I'm trying to learn how to play the guitar.
Good.
Problem is I spend too much time futzing around with this stuff.
Uh-huh.
So anyway, again, I don't want to bore all you guys with defining all these different toolpaths. Maybe I'll highlight a few things that are a little different, like for drilling.
Mhm.
What I like to do in a drilling operation.
A question before we go.
Sure.
I noticed that you did not have tabs. And the body
no,
is
that's
tabbed out.
Yeah, that's a
What
really good
is
question.
Yeah.
On the body profile is where I put my tabs, and I'll show you where that's at. So this is my 2D contour. So now it's a contour operation here rather than a pocket. With the
contour, your word for profile cut?
Yes.
Okay.
Well, contour is Fusion's name for profile. I still call it a profile.
Okay, got it. Thank you.
But Fusion uses contour. So when I have a toolpath with a contour operation, you'll notice in the geometry, it has a tab selection.
Got it. All right. Thank you.
And basically all you do is you tell it the type of tab. You can have rectangular or triangular. I think Vectric supports both. You tell it the width and height, and then you can either have it automatically position tabs. With this particular geometry, I don't want it automatically putting it on the inside of the curve. Yeah. So I say at points, and then I define the points. And you can see my tabs here. Here's one here, here's one here. I put 6 on, 1, 2, 3, and then up on the ends, 1, 2, and 3.
Yeah.
And then when you generate the toolpath, well, I don't even need to simulate at this point. You'll see the toolpath. You'll see it hop up from there.
Yeah.
Well, would you put this where you want to attach a strap? Because you're going to have to do that as an additive machining step afterward.
Attach a guitar strap?
Yeah.
Well, by the time the students are attaching guitar straps, they've already sanded off all these tabs. And then there's a lot more finishing operations they have to do. In other words, they route out the contour of the profile. They'll do a round over on everything. And then they have different choices where they can mount the strap buttons as well.
Oh, okay. So there's additional machining after this main machining.
Yeah, the only machining that happens after the CNC at this point in time is we let them route over the profile. I'm trying to think if there's any other machine. No, everything else is sanding, as Mike can attest to. Lots of sanding.
That sounds like punishment.
That's right. One thing I wanted to point out too, so let me go back to the simulation, and I'm gonna make it go through it really fast. And you can see my finished, all my my features are done. But the nice thing is whether there was a flip involved or not, I do see all of the through holes. I can even see the holes. It's hard to see it, but you can see the holes through the ferrule. So the holes were drilled through for the bridge and the bridge mounts. Or the mounts weren't drilled through, but the string holes were drilled through. But on the backside, there's ferrules that are mounted, and it's really critical that those line up perfectly. And if you zoom in far enough, you can actually see that they did line up and everything.
Can you turn off the tool path lines so you can see the finished result?
Yeah.
Okay.
Now, one thing I don't really know is, and I noticed this last time I was doing it, you see this is dark pink. These are more of a tannish color.
Yeah,
I don't know why it's defining certain colors in the different machining operations.
Are those 3 at different depths though, where the 2 pockets are one depth and the purple one is maybe a different depth?
They are different depths, and they are also different separate operations. So it might be highlighting different operations with different colors.
Right.
If we can see through these ferrule holes. It's not really clear that those are going through. So there may actually even be a problem there. I may not be drilling all the way through. I would have to check my drilling operation whether or not those are matched up right. as far as depth. And that's another good thing with the simulation is you can verify these things well before you get to the CNC. Oh, drilling, I was going to point out drilling. Let's see, close this. So the drilling operation looks a little different, obviously, than the pockets and contours. One thing I like to do is you can define your drill cycle, and I typically will use a chip breaking where you're pecking down at a depth and then pulling it back out. So you're clearing your chips out as you're going deep. And some of these drill holes are almost 2 inches or 1 3/4 inches deep. So you can define a peck drill operation rather than just drilling straight through and trying to make it all the way through. So that's one thing I wanted to point out in there. The drilling operation is actually pretty simple and straightforward. The geometry, I will typically pick the geometry. I'll pick the side of the hole as it's defined in the design portion. And then it will know where the hole is to drill. One thing that's interesting is our CNC, we only have 2mm and 2.5mm drill bits that fit in the collets that we have for our CNC router. But these holes are much bigger diameter than the 2.5mm.
Yeah.
What we have students do is finish drilling those either by hand or on the drill press. But when you run the simulation, you can clearly see that my drill hole with my 2.5mm is not the full diameter of the drill hole. So that's another handy thing with the simulation. You can see your original design versus what the tool is doing and know that there may be a discrepancy there.
Is there a reason if you wanted to do those on the CNC that you couldn't use a smaller diameter flat end mill and spiral your way down?
Yeah, due to budgetary constraints.
Enough said. Good enough. Good enough.
We only have a 1/2 inch collet and a 1/4 inch collets for the router, and then we have a drill holder that fits in that 1/4 inch collet that holds a 2mm and 2.5mm
sleeve or something. Okay.
Yeah. So again, without going through all these toolpaths, again, they're pretty straightforward toolpaths for this setup. And there's a lot of repeating operations. Somebody asked about copying. You can actually copy each of these toolpaths if there's common elements to each, and then just modify the geometry, for example, if that's what you want to do. So again, there's a lot of commonality between all of these, and there's really no point in going through each of them. But I'm happy to explain more or go through an individual one or anything else you guys want to try to do.
Well, I'm just kind of wondering about the tool changes.
Yes.
I thought I heard you say that they always have to go in a certain depth. So do you have like a washer as a stop so that all the bits kind of like bottom out in the collet, or how do you adjust so that you get accurate bit into the collet?
Actually, can I ask a follow on? Because I think, Paul, you're talking about, at one point, Ray said that you specified in the tool how much of the shank was protruding out. But I don't think, Ray, you were saying that was how you get your zeros. You do a touch plate for 0, right?
Yeah, we touch off in Z.
Okay.
Oh, okay.
Yeah.
But the other one was so you could actually see collisions in your simulation.
That's correct, yeah. And unless you mount the tool differently than what you've defined it, you're not going to see that collision.
Right, right. Are there other debugging techniques that are there in Fusion when you have defined your tool paths and you want to find out if, other than by just observing, you went through into the spoil board, or you I don't know, didn't have any tabs, your piece broke free, or is there any weird stuff that just like it tells you you've got a problem?
I get those little yellow warning
Yeah.
lights sometimes on toolpaths, and you just have to backtrack it and figure it out what they're talking about. I would say pay attention to those for sure. And then if there are operations that are not valid, I've seen like these little red stop signs come up, but I can't think of anything offhand that it's complaining about to say, oh, well, it figured that out because.
Yeah.
So there are some tools. One thing I didn't show you guys is actually how to generate the G code, which is
Yeah, please.
probably the most important step. So you can generate the G code all the way up at the top of the setups, or you can generate it at each setup, or you can actually generate G code down it for each individual tool. I'll do it
those
for,
three layers again. Where?
you can go all the way to the top of setups and
Yeah.
say post-process.
Okay.
So that'll generate it for everything.
Okay.
You can do it at, in my case, set up back and set up front. So
Okay.
before and after the flip,
Okay.
which is where I'll do it. But you can actually, even if you're interested in just one tool and what that G code is going to look like, you can post-process that one tool.
Yeah.
I'll do setup back and post-process.
Hey, Ray, just as a quick, sometimes we end up not having, say, set our 0 correctly. And so we're 1/32 of an inch from the bottom of a profile cut when we're trying to cut it out.
Mhm.
And so we can go back and we edit that one tool path and don't worry about the first 9/10 of that cut. Just set a different depth and go back and just do that one tool path to cut that last 1/32 of an inch or whatever. Is that where you'd come over to these individual line items? Like your one that says electric shoulder. Let's say we needed to go down just a little bit more. You just edit it there and then export it separately?
Yeah, you could definitely do that. The other thing is if you don't want to, you know, if it's just a temporary thing, like let's say my body profile didn't go all the way through.
That's the one, yeah.
You could always copy and paste that or duplicate it, then go in and change your final depth, put an
Okay.
offset in there, generate
Yep.
the G code, and then just delete that.
Got it. Nice and clean. Okay, good.
Yeah. I'll take that back out. Okay, so let's generate the G code. So post-process. Again, it's finding the post-processor from the machine. I don't know what the other option. Oh, you can actually pick a specific post if you wanted to. And because I had that Carbide 3D defined with my machine, it automatically picked that for me.
Yep.
Program number, I just always leave it. A comment, it's up to you. The document unit, so basically I'm in inches. It's going to generate the G code in inches. If you wanted to change that, for example, I was a member until they shut it down for COVID, but up at Make3, for some reason, their CNC router only worked in millimeters. And if you had all of this done at this point, you could then generate the G code in millimeters so that the CNC was happy.
Yeah, okay.
But in my case, I'm going to do just in my document unit. I don't know, the minimize tool changes, I'm guessing it may reorder the operation so that it minimizes your tool changes. I've never used that.
Yeah.
Open NC file and editor, we'll do this in a second. But also you can go down and you can set specific properties associated with this specific post-processor if there's anything unique you need to set up in there. Every post-processor, I think, has the ability to have these additional properties and variables. I can't think of any that you might want, like sequence numbers. I guess if you're reading G code and you want sequence numbers in there, you might want that. So I'm going to hit OK here. And it's going to ask me the location. Now you notice the program number became the number that was in there became my NC file. You can rename it at any point if you want to. I'm just going to save it. It'll overwrite one I already have. And then it will open it up in whatever text editor is defined for your machine. And then you can actually go through and review the G code if you want to take a look at it before you copy it out. It does put a little bit of comments in here. It tells me my tools. It tells me the machine that I was targeting. I put that comment in there. It added that. Then it delineates each of the operations a little bit. There's some comments. This is the 2D profile for electric, or 2D pocket for the electronics. So it's kind of nice because if you know your operation names and you want to just scan down to it, you can. Sorry about that. There we go.
So you do like a Control F or a Command F to find a certain part of the G code that's generated.
That's correct, yes. So if I wanted to go down to, like, I know I have a drilling operation there, I can find my drill ferrules.
Ray, are you looking at your text editor?
Oh, shoot. Yes, I am.
Yeah.
Sorry. Let me stop the share on Fusion. It's one thing I don't like about Zoom. Yes, I was pointing out all these great things that you can see, but you couldn't see them. So, yes. So
yeah, because I love reading G code.
Well, I do find it kind of interesting sometimes. You're like, well, why am I doing 2 operations twice in a row? You know, it's amazing what some of these post processes kick out.
Yeah.
Anyway, yes. So these were the tool definitions that I had talked about, the machine definition, some of the comment information.
Yeah.
And then each of the operations have a comment at the top. You can see my spindle speed. If it was a variable spindle, it's setting it to 10,000, even though it's all manual on ours.
It is variable with your thumb.
That's right. Yes, exactly. And then I think there's a cool and off operation in here somewhere. Anyway, but yes, you could, like, if I wanted to find a drilling operation, I can scan down for drill. I can see this is drilling my ferrule holes. And then it'll go all the way down to the end, and you can see end of program down at the end, the M30.
I'm trying to remember if you, in this output, basically caused it to stop between tool changes. Is that what happens?
So that's really up to the CNC controller to do that. There's 2 things that I find happening with the tool change, or that I see happening on CNCs with the tool change that doesn't have a tool changer. One, it'll barf, it'll stop and say unrecognized G code. Or it just skips through and doesn't do anything. Or ideally, what it will do is stop and say you need to change to this.
Yeah. But you're saying that that's on the controller side. It's not in the G code.
Well,
when it sees a tool change, it says, "Well, I don't do that. Therefore."
Yes.
Okay.
Correct. Yeah. So here you have an M6 for tool 1, and if it doesn't know what an M6 is, or it doesn't want to interpret that, it could stop and say you've got an invalid operation, or it could say stop. Do you want to continue?
Got it.
Various things can
Got
happen.
it. It's outside of the G code. It's the controller.
Correct.
Got it.
All right. So that's G code.
Can you tell us a little bit about this license you have, this educational Fusion license? Does that give you the manufacturing function?
It does. Now, you guys have that functionality, right?
We have it for the 30 days that we get after you register your software. It's not available to us long term. People have been looking into this, Rob and Mark Stuke and others. Apparently it has been there, but it's not going to be there, or it's already on a clock where it's turned off. And that's obviously, just so you know, when we set this thing off, Tim was trying to help us find the tool to use with all of our computer tools, so that we would just be able to come and design and output to our 3-axis mill or our laser or our 3D printer or our whatever. And this does offer that. And then all of a sudden we ran across this roadblock, which was, oh, and by the way, you have to pay for the manufacturer function going forward. And so it's not quite our panacea. And I guess I'm asking just because we, as a nonprofit woodworking shop, sometimes are looked at as educational, sometimes are not. And the educational license, if it comes with manufacturing, would be a kind of compelling thing for us to go try to seek out and get. But I guess I'm wondering, when your students take the class, they get the education. Is it as long as they're students at the community college?
Oh, sorry, I keep getting calls here, guys.
It's not Tim wanting his time back, is it?
No, it's not. But unfortunately, now it's 2 family members, so I hope
Oh, okay, okay.
it's not. Anyway,
How does it work with the students?
yeah. So at City College, you do not get an EDU email address. So that's been some challenges for us in terms of Fusion.
Oh.
And also, we don't appreciate the fact that Autodesk has kind of changed the rules for educational licenses and also for hobbyists and entrepreneurs kind of as time goes on.
Yeah.
So I know what you're talking about, but what I'll tell you is for the student license, what you're supposed to do is within 30 days, you're supposed to upload some sort of proof that you're a student, like your classes you're taking and your current enrollment and things like that. And that's how we've gotten around it without having the EDU. If you have an EDU, it's an automatic.
Got it, okay.
So I've got a student or an education edition. I've had it now for a couple of years, and they don't ask for recertification once you have it.
Okay.
But you got it at Palomar originally, is that right, Dallas?
Yeah, I think I did.
Okay.
Yeah,
remember,
everybody
it's
who's a
very
student
simple,
at Palomar
actually.
has an EDU email.
I didn't use the I didn't use the email. I think I just made a copy of my student ID.
Interesting, okay.
Yeah,
Just scanned
so
that and uploaded it.
So I think Autodesk is trying to figure it out themselves how to best do this. My suggestion would be is to sign up for an educational account if you're feeling like that's an okay thing for you to do, or you can justify it, whatever way you do, student of life, and go through the process of doing the educational license and see what kind of roadblocks you hit. And
Well,
if
we
you
just need
hit
to know
them,
what we would upload, because we have classes. We are a nonprofit. We do teach. I'm wondering if there isn't something like, I don't know, a clip from PunchPass, which is the system we use for our calendar and scheduling. And on the screen it says SDFWA education, and it says the class name or something like that. I'm just kind of curious if there's some sort of finagling we could do. But
well, why don't I do this, Travis? I've been in touch with one of their educational reps for the California Community Colleges. She's based out of San Francisco, but works for Autodesk. And how about I just put you in touch with her, and then just be upfront with it and just say, hey, look, this is our situation. What can we do to get Fusion licenses, and if at all possible, the educational licenses?
that would be great. I would like to take on that challenge. And
Okay.
Lance,
I was just looking on their website. Yeah, I know that folks have been sweating this for the last month, but if you go to that link, it specifically says on there that there's apparently a difference, and I don't profess to, I'm learning all this here, but it says there's a difference between manufacturing workspace, which, all of these on the top left, the design, those are workspaces, and then manufacturing extension. So I just was tooling around with mine. I know you can't see it, but it just popped up and said, hey, manufacturing extension was just added to your account free for a limited time. And then I clicked on it and went to this link, and it says, again, if you click on it, there's in bold, or not in bold, but at the very top, we'll know within a week or a little over a week, because it's until the end of May. But it does say, if anyone followed that link, it says we're giving free introductory access to the manufacturing extension. And then it says this change does not affect access to the manufacturer workspace. So I have to imagine if they're saying that the whole workspace isn't disappearing. And so when you click on the extension information, it sounds like it's adding, it's not entirely clear to me because I don't know everything, super well, but it's kind of like, here's what's included. And it seems like it's kind of like bells and whistles, like, for example, hole recognition and surface inspection strategy. So it sounds like they're like advanced bells and whistles for the manufacturing workspace. So yes. I feel my suggestion is that wait a week and a half to see whether this disappears for everyone, because I don't really think what's happening, in other words, like you said earlier, our capability of just exporting to the Prusa or to do what we saw today, I don't think they're taking that away.
Right.
Completely.
Yeah.
Well, I think a lot of us are confused. It's really unclear. I think it's because it's.
I
been
think they
moving.
added that language because of what has been. I'm sure we're not the only group of people who are
Exactly.
confused.
Yeah.
Well, that's why I posted that link, because I have a feeling they added that recently. Because I've gotten this page a month ago, and I tried to kind of check myself, but I just a thought.
Okay. Well, what
I
I'm
have
gonna
hope.
do, Ray's gonna hopefully put his slides on our forums. When I post this video, I'll also include that link, and people can start looking into what they interpret that offer to be. But Ray, if you also wouldn't mind putting me in touch with the education rep. I've had these conversations with Vectric and a couple of other people like SketchUp at the Trimble company. And sometimes you win, sometimes you lose, but you never know until you ask. So
Right.
I'd really like to have
Exactly.
this conversation.
Yeah, and to Autodesk credit, I think Fusion is picking up steam, which is exactly what they want, and they're getting a lot of interest. But I think what they're doing is they're going back and scratching their head, going, "Well, wait a minute, we've got too many free users, and we need to start making some money."
Right.
So I think that's why the rules are changing kind of on the fly.
That makes sense.
But my understanding initially was that the manufacturer workspace was available for everyone who had the entrepreneur or the hobbyist license. And if you go to 2D toolpath, you have access to basic toolpaths such as 2D Pocket, 2D Contour. If you notice, I think you guys can still see my screen.
Yes.
There's a 2D adaptive clearing that is only for professional licenses or the educational license. And adaptive clearing is just a better use of an end mill in the way it's doing pocketing operations.
Ray, I could live without that.
Exactly. And I think the other operations that we're all probably most familiar with are still available for the entrepreneur and hobbyist license.
I hope it's true. Okay.
And then the other one that I know that they're really being careful with is this generative design. I just had a seminar on this. And generative design is really this cool feature in Fusion where you define constraints for a particular part or product that you're trying to design. And then it will actually design the part for you using AI. It's a very expensive operation, but it's free for educational licenses, but it can cost a manufacturer or a design shop, it can cost them hundreds of dollars to run through this analysis.
Wow.
So they're being really tight. The only way you can get the generative design for free is with an EDU email.
Wow.
So even if you have an educational license with a non-EDU, you can't even use this feature.
Interesting.
Yeah, I have the education license and I do not have that pull down.
Yeah. Do you have a EDU email or non-EDU?
No, I do not.
Yeah. So that's the reason. Yeah.
Yeah.
I just had a class on this last week and they were explaining that because my students didn't have access to generative design either. And they don't have an EDU because City College doesn't provide that for their students.
Can you imagine the guitars you'd end up with though if you had it?
Oh, they're really cool looking. Yeah, it's this very organic design that they come out with and everything. It's really cool. I haven't had a chance to play around with it, but it's pretty cool. So anyway, the licensing thing, I'll put you in touch. Her name is Dee. I don't remember the last name, Travis, but I'll do a three-way email with you, and then hopefully she can enlighten you in terms of how it'll best work for you guys.
Thank you. I appreciate that.
Sure.
Is there more to this, or do you want to switch to maybe the gallery view and take questions from people?
I can switch to gallery view. I mean, I can talk forever, and I talk fast, and but I'm a little concerned. 2 hours, so. I'm a little concerned that I'm getting multiple calls from family members. So I don't know if there's something going on.
Right.
But I just texted one of them, and I said, "Is there an emergency?" And I haven't heard back. So. How about we take questions?
Okay, let's go. Why don't you let go of the screen and I'll put us in gallery view.
Okay. There we go.
Okay, folks. Now's your chance. Now, I have a question though before we get into gallery view, because I get a kick out of every time I see Lance, and he's got this simulated comic-like background. And then whenever we see his projects, they have to do with like 1990s video games. And I just wonder, are you in this world with us, Lance, or are you really just living in this virtual gaming world?
Right. No, I just live in a cartoon.
Okay.
And there's
Just curious.
no, I mean, I can prove it. There is a real, like, boring white bedroom behind me. Who wants to look at that?
Nah, this is much better. I agree. I agree. So here we've got a chance to talk with Ray about this last 2 hours worth of insight. Anybody got questions? Jim's staying on mute, resolutely.
How do you, if you can't order the neck kits, have you built necks on using Fusion for the?
Yeah, so the necks, for some reason, stem guitar, and I'm looking away, sorry, but I'm looking at my screen. The neck in Fusion, they keep as proprietary with stem guitar, and they will give you the STL, and you kind of have to reverse engineer it. There is a way, but if you're really interested in getting a neck Fusion design in Fusion, they have offered it to me, and I don't know what the conditions are, but there may be a way to get it.
But you've made them. So I guess I saw that it's not on the website. I mean, if you wanted to build a whole guitar, you obviously need a neck. So, but I guess then just to clarify, in your class, since you have access to that, you've also used it to carve on the CNC. Or do the kits, do they sell necks? I guess that's what I'm asking.
Yeah, the kits come with a neck. Hang on, I have one right here. So basically, this is what the kit gives you. This is your neck.
So you can shape the headstock.
There's some tabs in there still and everything. So there's more finishing operations there. You can custom cut a profile in the headstock.
Right.
They give you a fretboard, which is already pre-slotted. And then the guitar body, the reason I was working with this guitar body is this is a guitar body with that same, trying to get it in the camera, with that same shape. So basically, those are the 3 wood components you get with the kit. And then you also get all of the electronics and strings and, the nut, everything else to build the guitar out, except for the finish.
Ray, can you tell us if somebody wanted to take that class, they become a student at City College, they end up having to buy the kit. There's, of course, the tuition. Is it a 1-semester class? I mean, what it's all about? How does it work?
Yeah, that's a good question. And it was nice to have Mike in my class this semester.
You really have our lead in luthier in your class? Wow.
Sorry, Mike, I put you on the spot there. But yes, to tell you how you would take the class. So the class is considered an Introduction to Manufacturing lab. And what you're also required to do is take the Introduction to Manufacturing lecture class. They work hand in hand with each other, and they are a co-requisite of each other. You don't need to take the lab if you're taking the lecture, but you do need to take the lecture if you're taking the lab. And I might be able to provide some feedback on the lecture. I know the instructor pretty well, but I don't know how the class is, in terms of keeping your interest in everything. I think it's more about the student. If they're at all interested in manufacturing and lean operations in manufacturing and things like that, and getting an overall introduction in manufacturing, I think it's a really interesting class. I mean, it's kind of how I got hooked in it. Oh, you're on mute there. You're on mute.
Mike, what do you have to say about that? You're on mute too.
No, Mike's on mute.
I have airplanes going over regularly, so I have to mute periodically. Go ahead, Mike.
Okay. Yeah, I think he characterized it right. It's a good class if you have an interest in manufacturing. The instructor was pretty good. He well, I don't know what else I want to say, but it was a fair class, and it also brought in the electronics assembly part of the electric guitar.
Was it a
So-
one semester class? And how many times a week did you meet?
Okay, the other class, which is the 101 class, meets once a week, and it was like from 6:30 to 8:30 or something like that.
Mhm.
And it was, I think, 4 units, Ray?
3 units for that class.
Three, okay, yeah, and the guitar class, which is 107, was 1 unit, and it meets, it met the same night from 3 to a little after 5.
Oh, that's pretty good. All in one day then.
Yeah, now in the fall, I may go back to, in the last fall, I met 2 days a week, and students had extra time to work on their guitars.
Is it at City College in downtown?
Yes.
Yeah.
But I like the 2 day a week, teaching the 2 day a week, because a week seemed to be a long period of time between sessions, and people, you know, it's like when you're working on a project like this, you want to feel like you're making progress, not just for a few hours every week.
Yeah.
Now, in terms of enrollment, I will tell you a little trick that I did get a few people through in the class, is that if you have an engineering background, and I'm talking electrical engineering, mechanical engineering, whatever it may be, we can probably get you into the guitar building class with a waiver, so that you're not, if you're not interested in the manufacturing class.
Oh, really? Because I think pretty much everybody on this call has some sort of engineering background.
Yeah. And I did have, let's see, 1, 2, 3. I had 3 people that I was able to get waivers for who had various engineering backgrounds,
Okay.
professional backgrounds.
Cool.
And then you fill out like a 1.5 page, you know, justification for not necessarily having to take the introduction to manufacturing, and they were able to get into the class.
Okay. Well, that's when world gets back to normal, right?
Yeah, exactly.
Right.
Now, I will tell you that in the fall, it's not likely we're going to be able to offer the guitar building class in the fall again. Most of the classes at City College are going to online. There's a few labs that I think they're going to allow on campus, but I think they're more critical need labs, such as nursing,
Right.
and some of the other programs that are a little bit more important than building guitars. What we'll probably do in the 107 class this fall is a drone building class, because that I can do online and send people kits and work with them remotely. Whereas guitar building, you need quite a few specialized tools in order to do that.
Just out of curiosity, because of the topic drones, are you using some standard build out there?
So we work with a company called Action Drone, which is based in Chula Vista, and we utilize what they call their ADU Action Drone University drones. They're actually pretty simple. Like, you can put one together in a few hours. And I need to, if I'm going to offer this as an online class this fall, I need to enhance the project a little bit more than just a few hours. So it may involve some fusion work where they can design some of their own structure of the drone frame. They 3D printing. We have 3D printers on campus, and what we could do is have them design their frame or components. We print them out and then send them to them, and then they build them from there. But I need to make it more than just a 3 or 4 hour build in order to make it a semester long class.
Well, Ray, we have a lot of, Gary often refers to my favorite people in the community as nerds. And so we have a lot of nerds in our community, and I think they would be very interested in learning about these upcoming classes. So if you wouldn't mind letting us know,
sure,
we're happy to get the word out so that people can. There's only so much we can do in a woodworking community, but drone is just like a natural for a lot of the people who love 3-axis control machines, right? I mean, a drone is a 3-axis flyer, so nobody's going to be curious about that. So if you'd
like, and it's how Mike found out about the class, and Steve Corwin, is it?
Corwin.
Yeah, he's here.
Yeah. Oh, is Steve on? No, I don't see.
Oh,
hey, Steve.
I'm here. I just came late. I was like 20 minutes late. The MFAT 101 class we were discussing ran long tonight, so I was late for this.
Why did I? Sorry, I didn't see you. Are you on video, Steve? I don't see you in my little gallery here.
No,
I had my cam on. I was eating dinner when it started, so I didn't put the video on.
Anyway, yeah, Mike and Steve both joined, I think, through my efforts to come up and talk to you, Travis, about
Yeah.
some of the stuff. And you
Good.
put the word out, and that was great. So I
It
enjoyed
worked.
having him in there.
I
I
didn't
wish
have
we
a lot-
had the opportunity to finish it out.
Right.
I've
Sorry,
seen
Steve. Sorry,
guitar.
Mike.
I did get them
Steve-
before they shut down the campus. I did get them all their components, so I know they're working on them at home.
Oh, good. Good.
Yeah.
All
Well,
right.
Steve, I think, made a guitar a while ago. I mean, like
Steve
a couple
did?
years ago.
Yeah, I decided it
You
would be
did-
good to take a class as opposed to the whole winging it for a period of 5 or 6 years to complete one instrument. So,
Oh, okay, so you never finished it. Ah,
well, it's done.
looking
but
good.
It was more of a labor of love than a practical thing. So yeah, I was like, wow, a class, organization, instruction. I think I'll check that out.
Timeline, Steve, and timeline.
That's right. And
Yeah.
we in a normal semester, we have a 13-week, or it depends on the semester, but 13 to 16-week semester, 1 or 2 days a week. So we definitely have a timeline to meet.
That's great. That's great. Other questions before we wind this thing down? No?
Have you used any other toolpath generators? Or is Fusion the only one you've used?
No, I have Vectric vCarve. Before I learned about Fusion, I used Vectric vCarve. And in the lab, they actually installed the CNC with with Vectric Aspire.
Yeah, even better.
Yeah, even better. But those are the two I guess toolpath generation programs that I worked with, like in this, as a hobbyist and as an instructor. I've also, as a student, worked with Mastercam and SolidWorks.
Wow, cool. Hey, Jim, you had a question.
Yes, I did. I discovered, and maybe everyone knows this, but on the chats, you can actually save it, the chat, and it saves it as a text file right to your computer. So you don't have to wait until it gets published on the forum if you don't want to.
Oh yeah, look at that. I see.
I'm sorry, what is it you can save?
You can save all the chats right now,
Ah, right. Okay, yes.
and then you don't have to wait for it to come out on a forum.
Got it.
Nice tip, Jim.
Well, we didn't know what we would do with Tim leaving our lives, but Ray, wow, that was substantive, man. That was really good.
Yeah,
Thank you.
it is a lot to cover, so I appreciate you guys hanging in there.
But you can see from the fact that almost everybody was here the entire 2 hours that we eat it up. This was really good stuff. Now the challenge is to figure out what in the world Dallas can present next week that's going to raise. Did you see that look of shock?
Now, one thing I will do as a follow-up as well is I can share these Fusion files as a link, and you guys can actually view them in a regular browser. I don't know if you're aware of that in Fusion, but then from the browser session, you can actually download the F3D file and then load it into your own Fusion account.
Okay, great.
So I'll do that.
And I'm going to send you the link if you're not a part of our forums already, so you can go into the Fusion 360 area and post your what was you going to post?
The PowerPoint.
PowerPoint.
Yep.
PowerPoint.
Yeah.
Okay.
And then I'm curious, any thoughts on when we'll get the shop back open up there?
So Dallas is right here, so Dallas can answer, but he's going to have a session on Saturday, right, Dallas? You're muted. Hello?
Yeah, he's muted. He's like, there we go.
There he is. He's back.
I don't know why that didn't want to go. We're going to have a Zoom session on Saturday to talk about it, but the short answer is we're not too far out. We're doing quite a bit of work right now and getting ourselves ready. We're setting up what our new protocols will be and what the requirements will be for members, getting our shift supervisors ready. But I think we're it won't be too much longer. We haven't set a date yet, but I can see the date coming fairly quickly.
That's great. Great news.
Yep. Anything else, folks? Well, we'll figure out what we can do for next week. If there is something next week, then we'll get the word out. If not, then, well, we won't. But Ray, thank you so much. This was
Yeah, you're very welcome. Yeah,
really good stuff.
yeah.
And Linda
Very
says
well.
to everybody, thank you as well.
Thanks.
All right. Thank you,
Okay.
guys.
Bye,
Thanks,
everybody.
All right, thanks.